Comilla Higher Maths 2017, Question 1. In Question 1 we're given that the function of x is equal to 2x plus 3 over x minus 3, where x is not equal to 3. In Part A we want to find the value of the function of a minus 1. To do this we start with the function of x, which is 2x plus 3 over x minus 3, and instead of x we substitute a minus 1. Now that gives us 2 into a minus 1 plus 3 over a minus 1 minus 3, which in turn simplifies to 2a minus 2 plus 3 over a minus 1 minus 3. So we get function of a minus 1 is equal to 2a plus 1 over a minus 4. In Part B, we're asked to find the inverse function of the given function. Now in Part B, the domain is equal to the real numbers r minus the set containing the number 3. So let y equal 2x plus 3 over x minus 3 and make x the subject. Y equals 2x plus 3 over x minus 3. We need to get rid of the fractions, so multiply by x minus 3. Now the left-hand side becomes y times x minus 3, and the right-hand side is just the 2x plus 3. If we expand the brackets, that gives us xy minus 3y equals 2x plus 3. Now to get just x terms on one side and the other terms over on the other side, we'll need to take away 2x from both sides and add 3y to both sides. So that will give us xy minus 2x equals 3y plus 3. Now we can factorize the left-hand side, and that gives us x into y minus 2 equals 3y plus 3. And then we can divide by the bracket y minus 2, and that gives us x equals 3y plus 3 over y minus 2. Now to write down the inverse function, where we've got an x, we change it into f minus 1x, the inverse function x, and on the right-hand side, where we have a y, we change it into an x. So that gives us the inverse function of x is 3x plus 3 over x minus 2. Now in Part C, we want to show that the given function is 1-to-1, and is it onto. Now a function is 1-to-1 if you cannot have two different elements mapping to the same element. So it's 1-to-1 if you cannot have two different numbers x and y which when mapped function of x and function of y are the same. So let's assume the function of x equals function of y. Then we have 2x plus 3 over x minus 3 equals 2y plus 3 over y minus 3, simply substituting x and y into the function. Now if we cross multiply, that gives us y minus 3 into 2x plus 3 equals x minus 3 into 2y plus 3. If we expand those brackets, we get 2xy plus 3y minus 6x minus 9 equals 2xy plus 3x minus 6y minus 9. Now we have 2xy on both sides, so they cancel. We also have minus 9 on both sides, so they cancel. Now if we add 6x and 6y to both sides, we'll end up with 9y equals 9x. In other words, x equals y. So you can't have two different numbers mapping to a single number. If you do, they are in fact the same number. So the function is 1-to-1. Now, we want to find out whether or not the function is onto. If we consider the number 2, which is an element of the image set, if the function is onto, then there exists an element x such that function of x equals 2. So let function of x equal 2. That means 2x plus 3 over x minus 3 is equal to 2. If we multiply both sides by x minus 3, we get 2x plus 3 equals 2 into x minus 3, which expands out to 2x plus 3 equals 2x minus 6. If we subtract 2x from each side, you end up with 3 equals minus 6. Now that, of course, is impossible. So that means the function is not on 2. There is no element in the object set that maps onto 2 in the image set. If we had defined the object set as being the reals minus the number 2, then it would have been on 2.